Hello, check. Hello, check.
Hello and welcome to the 61st edition of FAYA Portable. But before we get started, let me express our sincere appreciation to all of you who are gathered here, as well as to all of those who have been supporting us with their presence and participation for the past 5 years. Now, as is customary, we'll kickstart the session with the Tech Bites. Now, Tech Bites is a session where we brief the advancements in technology that happened in the past 1 month. So I invite Mr. Vibros now to give the session.
Hi, good evening all. So, what is the news of the moment right now? Biggest news. So, yeah, and Microsoft, right? So let's start with that. Actually, after many months, I think many months of discussion, GitHub is finally acquired by Microsoft for $7.5 billion, right? So initially they were not, it was just like GitHub was planning to go for an IPO, and I think they made this decision after a discussion with Satya Nadella. Actually, Satya is the key person behind this, just because his face, after he taking charge of Microsoft, the core values or the way Microsoft was operating before changed a bit, but still people are skeptical about it. People are not seeing it in the right way, right? So what are your thoughts on that? So is it good? Why are you still worried? I think Microsoft is the biggest open source contributor right now from the corporate, right? So anyhow, people know that they made this decision not just seeing some business that happened using the GitHub repository, but there might be some motive behind that. And that is why developers are running different campaigns right now to move to GitLab, Bitbucket, etc. But still, it is a shock, and let's see how it will end up. But previously, Skype acquisition, some people say like Skype, it is bad right now, right? Some people say like it is okay, it's good, nothing happened to Skype, so it should be fine. This acquisition shouldn't create any trouble for us. So next one is GDPR. So what is GDPR? Yeah, General Data Protection Regulation, and it's by the European Union, right? So why do we need to talk about that? Is it something that should affect us if we are doing a business in India or if we are serving a customer in US? It is some regulation by European Union, right? For all the states under European Union. Why don't we have such a relation? Okay, so everyone is very much positive about that, right? GDPR, after Cambridge Analytica, everyone is like that. We need something right, like. Okay. So that's fine. So still, that is my question was like whether it is we should worry about it. Actually, we should, just because as per the regulations, any customer, if there is a customer who provide data from any of the states from European Union, then that website should be following the GDPR regulations. So as the website, it is open unless we are having restricted access to India, and we seem like nobody from European Union countries will be part of that. That is, we should follow that. And also the fines for this is just like it can go up to 4 million euros, I think, or even 5% of annual returns of the company. So it is just like one something that each company should be aware of. And I think like if you are a service company, all the websites might be changing its privacy policies just to make sure that they are within that regulations. So GDPR started do you know which date it came in place? May 25th, right? Okay. So, and is there a slide? Okay. So there are 8 rights for citizens. So let's have a quick walkthrough of that. Right to be informed. That means there should be a transparency in the data usage by any website. They should be transparent, like which are the purpose that they use our user data. Second one is right to access. We should know which all data they store about us. So data means personal information. That make us identifiable uniquely. And right of rectification means that is we have the privilege to get our data rectified if there is any change or if there is any mistake or incomplete data in any website or in anyone who stores that. Right to erasure. Erasure means the freedom to be forgotten. So what does it mean? If our data is stored somewhere, we have the right to get it deleted. Does it ring a bell? So we are here for a blockchain session. So is there something that we need to worry about blockchain in those years? Blockchain you can delete it, then how will you adhere to that rule? So there is something there that can be something that turn as a challenge for private blockchains, not actual blockchains. Actually, that is the blockchain. If it is a real blockchain, now nobody could sue them, right? And I think that will also in turn help us identify that is who are the real blockchain networks and who are the one who is spoiling the ecosystem. So that is the power of blockchain, and I think so that you should be walking through that. Then next is right to restrict processing. That is we have the privilege to cease or pause that you should not use our information. And right to data portability, it is just like that is we have the right to reuse our data or port it. And right to object is like that is we can object like our data should not be used for mass emailer or our data should not be used for other purpose, that is specifically. And finally, rights of automation, decision making and profiling. So that is like any decisions that is it is protect individuals against the risk that potentially damaging decision. That is something that can be created used to automated decision without human intervention. If some decision is made, that is it will protect us from that. So those are the 8 rights. And if you want to know more about it, I think on the 12th of this month there is a session that is happening on Malabar Hall Park Center on the GDPR. Next one, Google I/O. It happened in May, and I think that we do not need to play this video because it tells a lot of information that what Google introduced this year, and mostly it is just like AI enabled or advanced AI is applied to photo. Different application will become better AI enabled. And one interesting thing that went viral last month was the duplex. So if you want, I can play that. Do you want to play it? Everyone has seen that, right? So it is just like a virtual assistant making a call on behalf of the person and making a booking.
I'm looking for something on May 3rd. I want a haircut for a client. I'm looking for something on May 3rd.
It turns out a big part of getting things done is making a phone call. We think AI can help with this problem. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule an appointment for you. Let's listen.
how can I help you? Hi, I'm calling to get a woman's haircut for a client. I'm looking for something in the third. Sure. Second? Sure, which time are you looking for one? At 12 p.m. We do not have a 12 p.m. available. The closest we have for that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, you have it 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Have a great day.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when you're done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but you just not easily able.
Yeah, so it is just like making a call on behalf of us. That is also like making there was a lot of trolls about it, right? That is making wrong decisions on behalf of us. And next one, AWS Neptune or the graph database. So AWS Neptune is the key toolkit of Amazon. So and the knowledge graph of Alexa. So now it is available for general public, and it enables millions of relationships in milliseconds. So standard use cases of Neptune include application, recommendation engines, fraud detection tools, etc. So one more thing that I want to mention is about the Singularity University Global Impact Challenge that is about to happen on next month, July 7th, that is July 2 to 6. So during the break session, we will go into more details. So it is just like one of the biggest event that is about to happen in Kerala. So from Singularity University, that is it is conducting a challenge called Global Impact Challenge, where the winner of that event will get incubated in California at Singularity University's space. It is worth $50,000 or something. That is all the travel, accommodation, everything that they will take care of. And it is in finding solutions for the global challenges in environment, health, and medical. And tomorrow is the last date for application. And also the winners, all the final participants, that is Kerala government will be taking care of the food and accommodation, and they can go through a boot camp of startup for 5 days. And there is also 80 lakhs the government grant. They will be eligible for pitching for 80 lakhs government grant. So that is something that if there is any questions that we will discuss in the break. I think that's all for today. Thank you.
Okay, thank you, Deepu. Now, without any delay, let us move on to the star session of the day. Decentralized applications using Ethereum, a hands-on approach. The session is led by Mr. Sriraj S., co-founder and chief architect of Trivandrum Global, a company focusing on blockchain solutions. He has made many contributions to the development of blockchain platform. So I invite Mr. Sriraj to handle the session.
Hi all. So great seeing this much people after work hours. So let's start with the blockchain question. What is blockchain? How it works, things like that. So let's start with GDPR. Many of you said you think about GDPR. So why do you think actually GDPR is in conflict with blockchain technology? Anyone? Anyone? So actually GDPR is trying to make some of the data of users private. So what blockchain is doing is actually the same, but on a different standpoint. So what blockchain is doing is creating privacy for you, but actually making all the data public. So that's the encryption part for blockchain. Every data is public, but everything is encrypted. So even though it is at first standpoint contradicting with GDPR, there are many workarounds to work with GDPR. So what is blockchain? You might have heard this a lot, but according to me, blockchain is a transaction authentication system. Like transactions can be anything. Transactions can be monetary transaction, it can be data, it can be anything. So how are we verifying transactions right now? So in classical databases, permissions are defined for a user, and users might be using passwords or key phrases for authenticating an update or a data change on a database. So what's the current problem? Current problem is when working with a huge network. Say, what are the data transactions? For banking, you are using, say, Federal Bank, and you are transferring, say, 10,000 rupees to an ICICI bank account. So Federal Bank is transferring this data to NPCI, National Payment Corporation. They are transferring this to RBI, and RBI is laying back to the second bank. Then they are checking whether their databases is correct. Then they are paying back whether they can credit or debit the transaction. Then they send back to the sender, okay, this transaction can be processed. Then they relay back information. So this relaying back of information can cause a lot of trouble in a database. So these are called concurrency issues. So there's a lot of reconciliation needed for a blockchain database, novel databases. So in banking field, what happens is that you might have faced the payment failures. So how this happens is, say you are transferring 10,000 rupees to bank A to bank B. So when these informations are relayed, at some point the core banking softwares might crash or have a mishap. So at that point, where the data is, that's the important point here. So bank A is now RTGS, NEFT, IMPs are all following a debit first architecture. That's like they are saying the amount has been debited. Then they are sending information to the bank B and asking for them to credit. If somehow bank B is not able to credit, bank A is recording a transaction as credited, bank B is not having any transaction record. So this process is called reconciliation in banking. So this is a problem faced by many industries. Many industries who are using distributed databases, or they want a single set of data or a set of data, but they don't have the means of accessing it parallelly or at the same time. So that's why blockchain was introduced in the first place. How to access data at the same time without having the problem of reconciliation. So the network effect you might have heard about. So it's like one of the most important theory that's correlating with internet. Like how strong the network is, that much strong the single users are. So if network itself are expanding very largely, then everyone has the power of the whole network. So to exploit this thing in blockchain, they created this decentralized or distributed ledger. So distributed ledger is, as I said, everybody is having a common database or a common file. So every transaction, I'm mentioning again, transaction can be anything. It can be an asset, digital asset transaction, or it can be a data transaction. So all these transactions are recorded on a single file or a single database. These databases are circulated around every party. So the authentication here. Authentication is a verification of a transaction. So 10 of you have a distributed ledger, and person A wants to change the ledger, add a transaction to it. So the 9 of you has to verify it. So, or at least 51% of the network has to verify it. So the system believes that if 51% of the network says that this transaction is true or correct, then the system believes the transaction is correct. So as long as the network grows, the amount of 51% also grows. So that's where the network effect comes in. That was the network strength for the blockchain. So as blockchain or the public blockchain grows, the strength of the blockchain or security of the blockchain also grows with it. So it's called a 51% attack. So if you control 51% of the Bitcoin network, you can make a fraudulent transaction. You can fake a transaction in. So you might have heard about minings, and now a lot of companies are acquiring a lot of mining rigs, and it's said that around 90% of the mining capacity is being distributed on 10 or 11 companies. So suppose 5 or 6 of them join hands, they have the 51% of the network, so they can crack the network. So this is one of the most important challenge we are facing. So blockchain is evolving a lot. One of the most important challenge they are facing is security, and the network effect is the one which is going to solve the current problem. So distributed ledger, as you know, it's a shared, continually reconciled database. So I hope you all are familiar with the basic blockchain steps. So the node, what's a node? Node is anything that's connecting to a blockchain. So a node can validate and relay informations. They can either say that this transaction participate in validation, or they can just relay the informations. So there are 3 types of nodes. One is a full node. Full node, if you have used any clients for Bitcoin or Ethereum, the Bitcoin full node is around 120 GB. So it's the full blockchain. You are downloading the full blockchain. Anyone from any part of the world, if they are making a transaction to the Bitcoin network, you will have a copy of it. So this is the full node. So go to that's the miners. Miners are full nodes, but they are verifying the transactions. So any full node can act in different roles. A node can create transactions, relay transactions, verify transactions. Verifying transactions are the miners. So the second one is lightweight node. That need not be a full node. They shouldn't store the blockchain, but they can create transactions, relay transactions, basic stuff for blockchain. So as I said, validating. Miners are validating. So what's the validation method? Like in classical databases also, there are a lot of validation methods. There are multi-signatory validation methods. So what's the difference between blockchain? So it's called consensus. So if it's a 10-party network and you're sending the information to 9 people to verify, yeah, they can check the data and say yes or no. That's the basic verification. In a network, the problem is how to verify the verifier. Who is verifying it? What's the validity of that? So every node has to be verified. That's where consensus comes in. Say if there are 10 million nodes that's verifying in the Bitcoin network. As I said, if you have 5,000,001 node, you have the 51% of network. You can crack the network. And if there's a verification method for the nodes, suppose I am creating a swarm of bots, a swarm of fake PCs with different IPs and different MACs. I can make, say, 5,000,001 species duplications, and I can verify the whole network or the transaction through my PCs. So every node needs to be verified, whether they are a valid node or not. How do you verify the validity? It's called a proof of work. That's the most important consensus that's used by Bitcoin, Ethereum, and all the public chains. So is just a concept of saying I am a physical machine. So to say or to verify that I'm a physical machine, it has to spend some computational power. If it's spending some computational power, it's considered as a valid node. So if every node has to say spend or crack a computational complex that's worth 10 minutes to solve, then I can't make a fake node or fake computer. My fake computer can only act as a single computer. It has the processing capability of only a single computer. So to take out the duplication problems, proof of work was introduced. So as you know, proof of work has many limitations that makes normal computers not to be able to mine. So earlier, normal computers could mine a transaction, but later on, ASICs, application-specific integrated chips, came in, and chips that were specific to mining were created. So these were created in an array of or a farm, and these farms were called mining farms or mining rigs. So that's how the computational power or the mining capability all accumulated to 10 or 11 companies. They all started making ASICs used for mining. So normal computer can't mine any Bitcoin right now. Earlier you could have in 2010 or 11. Now you can't. So this problem has also another consequence. These computers are spending, and this power is enormous. Like it's worth 2% of world's power. The whole Bitcoin network is operating, or it's costing world's 2% of electric power. So just imagine the scale. So it's not at all green or not at all environment friendly, and it's also costly. So that's why a different other proof of systems has emerged. One of it, the second one is proof of stake. It's like if every node has to say credit or keep 10,000 rupees, then I can't make a huge number of fake accounts. I may be able to make 10 or 12 fake accounts, but I can't make 100,000 or 1,000,000 fake nodes, because I'll have to spend real currency or real stake to the system. So each system has a stake. So for Ethereum network, each node will have to have a certain amount of Ethereum stored inside the node itself, which is not spendable. That has to be the stake. Then only the node can participate in the network. So the next one is proof of time. It's the concept where how much time a node has spent not verifying a transaction. So it's a little tricky. So let's not get into more details on that. These are the just basics of the network stuff. What's the difference between database and blockchain? This is one of the most important questions many have right now. Like everyone's hearing about blockchain, and I have seen many Quora posts and a lot of Facebook posts that blockchain is not that different from distributed databases, and like it's just a beefed up bubble. So what's the actual difference between distributed databases and blockchain? So you might have used Google Docs. So you might have shared Google Docs between different people. So sometimes when you edit, you can't make changes, and it says it's locked out of editing. It says that someone else is using it. Please wait for them to make or save changes. So this is also another problem faced by classical databases. That's the concurrency issue. If two data changes are coming in, which one to process first? This is a concurrency issue. So this is effectively solved in cryptocurrencies and bitcoins. Changes are accepted. So in the example I mentioned about banking system, so it's a debit first architecture. So the bank A is saying that it has been credited without any confirmation from bank B. So this is also another problem faced or seen in classical databases. Many changes are accepted first, then reconciled next. So all the changes, because of the concurrency issue, not to miss out any changes, all the changes are accepted first. Then these are reconciled to check where errors came in. So these are all applicable to distributed databases. Imagine a bank or multiple nodes using a single set of database. Middleman. So to relay or make a communication channel between different parties, there needs to be a middleman. Suppose you are sending a message from Facebook account to another Facebook account. So it's being relayed to Facebook server 1, 2, 3, and many other servers, and then it might come to user B. So Facebook is a middleman. You have a data transaction without a middleman. In banks, RBI and PCI are the middleman. So these three problems are solved by these are the major differences between classical database and a blockchain. So this is the three T's: transparency, traceability, and trust. So this is a use case specific definition, like what does blockchain provide for businesses? So blockchain provides transparency. Transparency in the sense, as I said earlier, they are creating all data private by making it public. So all data are encrypted format, but these can be seen by everyone. If I hold an Ethereum account or a Bitcoin account and I have a balance of say 10 BTC, if anyone has my account address, anyone can view my balance, anyone can view my transaction histories. It's all public, but they don't know who. If I go to etherscan.io, I enter a random Ethereum address, I can see the transactions, I can see the balances, but I don't know who the owner is. Yes.
So actually, my question, suppose if you need to send you some information, you'll be giving your access. So I'll be knowing the correspondence.
Yeah.
In that case, your files will not.
Yeah. If you know a person in physical world, then it's true. But we are talking about a whole network. So suppose you are transferring anonymously to a person. So there's different definitions and different needs for anonymous transactions. That's not really into black markets and all the stuff. But there are some needs where anonymity is necessary. In that case, yes, it can provide. And also there are linking methods which are used to link a physical person to cryptocurrency addresses, whereby the physical identification is not.
I didn't get that data point. Like he said,
So like the earlier gentleman said, if you actually have on your website your address, Bitcoin address, right? I can go and trace back all your transactions, correct? So I have essentially doxed you on Bitcoin. How does that actually, I mean, you said that you can do that and you can create an anonymous transaction on the black market. But if I know one Bitcoin address of yours, and then I can keep continuously monitoring that, I can essentially trace your all the transactions that are happening against you.
Okay. Hello. Okay. So now might be a good time to talk about black market. So how did some black market deals get busted? Like many were selling AK-47s, drugs through darknet and dark web. So many were using cryptocurrencies. And NSA cracked some of these deals and busted some major dealers. So you might have heard about the news about Silk Road, Silk Market and all. So there are different darknet websites related to how does they track? One of the major bust was because someone bought a coffee from Starbucks using cryptocurrency, which that account was linked with a arms deal. So if you are linking your account with physical transactions or physical world, then you are sure you will be busted. If you are not using this account to interact with any physical environment, so physical environment in the sense, if I am purchasing a coffee from a coffee shop, they will have the address. So these address transactions will be monitored by NSA on a huge basis. Yeah. No. Say I am selling 10 AK-47 on darknet. So someone is able to buy or want to buy 10 AK-47s from darknet. How does the deal get busted? There are two endpoints. One is the transfer of money, and second is the transfer of goods. So if I am if the buyer is coming packing 10 crores in 2 suitcases and coming to me, and I am delivering 10 AK-47s by hand, they have a direct connection. If he is sending cryptocurrency to me, my identity is anonymous. My website will show I am a AK-47 seller and this is my address. His ID will show this address and I have 10 BTC. So from my standpoint, he is qualified as a buyer. His standpoint, I am qualified as a great dealer. So he transferred 10 BTC. I send him over the AK-47. Still, that's the good transfer is still linked to a real world. Monitoring? Which address? No. There are different privacy settings. Have you heard about Monero?
So one thing for sure that it shouldn't go get diverted.
Yeah.
First of all, this is the fourth session here on blockchain. Basics of blockchain, and the second session we had on advanced blockchain, and then all these went to Bitcoin discussion. And then we had a specific discussion on Bitcoin itself. So the other session completely on Bitcoin, and this is the fourth session. And when asking about the session, then let's talk on Ethereum. So,
yeah. So just to answer that.
We have to get to the topic.
Just to answer that, there's a whole different level of developments called privacy coins. Monero, Dash, CryptoNote, there are a lot of coins which are focused on privacy. What they do is that they obscure the address and transactions. So in Bitcoin also there are third-party frames. Have you heard about BTC Relay? It's a service which is used to obscure a transaction. So in Monero there are 6 rounds of hashing used to obscure an address. So you can't really know the address. That's the principle there. If you are showing so and so's address, when you search into the Etherscan, there won't be an address listed on that specific reference. If you're sending money to it, it will be linked to a different account, it will be linked to a different account, it will be linked to a different account. Then it will relay back to any other account. This can't be traced. So there are workarounds for this too. So that's how the black market dealer got busted. Like he made a physical transaction. So as I was told about, earlier, it's a privacy concern. It's evolving. The traceable, security concerns, it's evolving. Scalability concerns, it's evolving. A different type of protocols are coming. So it will take time to be usable for everyone. Now it can be used for only specific use cases. So public versus private, you might know, everyone, permission chains and non-permission. So we are talking about public chains. Public chains in the sense there is no permission, every data is available to everyone. Ethereum. So what Bitcoin does to blockchain world is that they have enabled payments. It is a financial transaction method. So different blockchain platforms are trying for different things. So as I told, Monero is a privacy coin specific to privacy needs, whereby users' transactions and balances all can't be traced. Bitcoin was for micropayments or basic payments between two people, peer-to-peer payments. Ethereum is a self-sustaining, censorship-resistant, decentralized computer. So it's just a computer. It's called the Ethereum virtual machine. You're uploading some code to the Ethereum virtual machine and the computer will execute the code. Just as simple as that. It's a computer, Ethereum virtual machine. Still, there are data transactions and monetary transactions. Ethereum has a currency. It's called ETH. It's the basic value of or the basic asset that's transferred among Ethereum accounts and Ethereum machine. So what's it's used for? Distributed data storage and computation. Any kind of data storage or computation where multiple parties are required, you can use Ethereum. What are basic processes? You need to connect to a network. So that's where node comes in. I've mentioned about nodes. There are three kinds of node. Only a node can connect to an Ethereum network. Node can perform various kinds of transactions and validation transactions. Basic stuff, and there's running smart contracts. So these are the three basic functions used. We use Ethereum for. Ethereum network, let's go to. We have smart contracts. You might have heard a lot about smart contracts, coding in Solidity and all. So smart contracts are self-executing code and activated by sending Ethereum onto it. You write a piece of code. It's not that big of a code actually. It's just a simple logic. If this, then that. That's the basic logic for a smart contract. For an ICO, you might have heard about ICO. Anyone who doesn't know ICO? It's cryptocurrency corruption. So you buy tokens during an ICO. So during an ICO, what happens is you send some money to that address. You receive tokens equivalent to that money in your address. If you send that money to that smart contract sends you back the tokens. That's the basic function for a smart contract. A simple smart contract. If this, then that. So this is, when it's uploaded to the Ethereum network, it's blocked. Anyone can access it. So how to access a smart contract? It's by a transaction. So if you're sending a transaction to the Ethereum network, function in that smart contract, it gets executed. It doesn't need any of your help. It's a global computer. It's by selected nodes, and Ethereum virtual machine is an interface for running your code. It's a runtime environment for smart contracts. Ethereum virtual machine is where you send the smart contracts and upload your smart contracts. And there's accounts.
So it will be great if you could give a use case so that people could start relating to it.
Yeah. So smart contracts, you might have heard about tokens, Ethereum tokens. So anyone knows what Ethereum token is? Simple. Okay. An Ethereum token is a representation of a digital asset. So this gets to economics more. What you're doing in your company is that you are representing your shares, right? 100% of shares. You are dividing it to 4 or 5 people. Just like that, tokens are a representation of a good service value anything, may it be a currency, may it be the valuation of your company, anything can be monetized into a token. So you are buying the value. So in Kickstarter you might have seen you are funding different projects, but the limitation of Kickstarter is you can fund only physical products. So what if you can fund fungible assets, non-fungible assets, anything, physical, non-physical? You are representing a value of a company. What stock markets? You are representing the value of a company. You are believing the valuation of TCS. TCS cost a huge amount right now. So how are you betting on it? You are betting on the supply and demand, basic economics. You are valuing a company that it's 1 billion or 100 million, and second person is valuing it as 200 million. So they'll be asking for you to send this or buy this thing for 200 million. So this is how the market regulates. You might have heard of exchanges. So this is the buying principle for exchanges, supply and demand. So if someone is willing to buy a token for 100 rupees, the demand is 100 rupees. If someone is willing to buy it for 200, the demand rises. So this is how the price goes fluctuating. So Bitcoin doesn't have any fungible value. It doesn't have any physical value. You are just assuming that it has, say, 5 lakh worth value. Just like that, can be anything. Your company can be represented as a token. So then it goes to different types of tokens, security tokens, different types of tokens. So one of the important part you need to think about tokens is utility. So if you heard about any token, does it have any utility? Ethereum's utility, Bitcoin's utility. Bitcoin's utility is for transferring money. Ethereum is also used for transferring money. But Ethereum's prime utility, Ethereum is a blockchain that has the Ethereum virtual machine. Its prime utility is, Ethereum currency's prime utility is to run smart contracts. To be able to deploy smart contracts, you need Ethereum. So you are paying Ethereum to run a smart contract. So it's like a cloud service. When you are hosting something on Amazon cloud, you are paying Indian rupee as a fees for the service. Now here, Ethereum is the fees for the service. Just like that, different platforms have built different service offerings. And all these service offerings, you are paying with a specific token. Suppose in, say, Tron. Tron is a mainnet. So EOS is just like Ethereum, another virtual machine. So you are using EOS currency to pay for that smart contract, deploying that smart contract, performing operations on that smart contract. So this is the utility for a token. Your utility can be anything, not necessarily related to blockchain. If you are setting up a coffee shop and you are launching a coffee token, and you are saying if you pay here using coffee token, you'll have 50% discount. So that coffee becomes a utility. It has a utility. Just like that, tokens may have utility or may not have utility. So these are the basic token stuff. Now we need to look into accounts. There are two types of accounts. One is externally owned. So this is the normal account you see where you have a public key and a private key. So public key, it's identifier for you. It's like a username, and private key, it's like a password. So public key is the one which everyone sees. Private key is used by you to access your account to verify a transaction. Internally owned are owned by smart contracts. This is a separate type of accounts which are used by smart contracts only. So when you are uploading a smart contract to the Ethereum virtual machine, you get back address, contract address. That's the identifier for your contract. So there's no name for the contract. This is the identifier for the contract. So that's the second type of account. And third one is gas. So gas is an important thing for it. As I said, for service of Ethereum virtual machine, you need to pay Ethereum. So this is called gas. When you are using an Ethereum virtual machine, when you are uploading a smart contract, when you are interacting with a smart contract, any kind of transaction, you need to pay some Ethereum. This Ethereum is called as gas. So because Ethereum's value is fluctuating, it has been divided into its gas amount and gas price. The gas price is related to Ethereum. Gas amount is fixed numbers. So let's say for operating this transaction, I'm saying I need 0.1 Ethereum. 0.1 Ethereum will fluctuate. So there's no stability in that. That's why gas has been introduced. And for every transaction, so say if I'm having a smart contract, in every smart contract there will be certain operations, say A plus B. It's an arithmetic operation. There's a logical operation. Any operation which changes the state of Ethereum machine or Ethereum network or the blockchain itself, any state changing transaction requires gas. So let's say I'm looping for I is equal to 0 to I less than 10, I plus plus. The loop runs for 10 times. So the whole Ethereum cost would be into 10. For executing the loop once, it will be like 10 gas. It will be 100 gas totally. So every logical operation, be it temporary or permanent, if you are just using a int I inside a loop, it's a temporary operation. But in Ethereum machine, it's performing a transaction. So for performing each transaction, you need to pay gas. Each transaction is identified by its opcode or its object code. So every transaction might have, if you have used any embedded systems or embedded C, opcodes, you are sending to 8085, 86 opcodes only. So these opcodes represent a code. Say for I is equal to 0 to I less than 10, there is an opcode for that. So each opcode will have a gas value associated with it. These gas will be calculated up to say 10,000 gas. For the smart contract to be uploaded, it requires 10,000 gas. And each gas is say 0.0001 Ethereum. So you need to pay this much amount of Ethereum to the network to execute this transaction. So this is how gas payments work. And yeah. So so miners are the one who's defining the gas value for Ethereum. So this is a current gas value for Ethereum. So it's like standard cost for a transfer, $0.089. Yeah. No. So the Ethereum virtual machine concept is something like this. The transaction is verified by the miners, but the Ethereum operations are done by Ethereum virtual machine. So when you're relaying a transaction, say A plus B, the Ethereum virtual machine will do A plus B, and this state change will be added by the miner. So one who is verifying that transaction, you are paying gas to only that platform. So in mining, it's something like this. So the block time for Ethereum is 15 seconds. So every 15 seconds a new block is added. A block might have different number of transactions. Only the person who is defining the block header. You might know about blockchain, a header and hash is reference to the next header, things like that. It's how the chain is built. So one who is creating the block header, he is getting the mining reward. anyone. That's selected by random. So that's why the consensus mechanisms are important. So in proof of work, a random person is selected. In proof of time, a person who has most elapsed network time is selected. So there is a regulation for the mining reward. So in classical proof of work systems, it's a luck. If you get the block header, then you get the mining reward in turn. It's, let's see, if I am having one node in the Ethereum network and a company is having 10 nodes, so who will be having the most probability in getting the block header done or block header verified? Obviously that company. That's why I'm posting this much. Yeah. No, EVM is not running in every node. So EVM is a virtual machine instance. Ethereum virtual machines are running on only selected computers. It's not running in every mining node. Even I can mine. I can download the Ethereum blockchain and I can start my miner. Not necessarily my mining system would verify an Ethereum transaction, not necessarily it will act as an Ethereum virtual machine. So these are selected high computational facilities which are being used as EVMs. Yes. So there's an Ethereum network. So you might have heard about ERC standards. There's ERC20, that's the standard for. So there's that question: who decides these standards? There's an Ethereum community, and you submit for it. No, the community will. How staking is like a stake. 21 nodes are selected to verify every transaction. So 21 nodes will be verifying every transaction. So let's switch to proof of stake. Then there will be a voting mechanism. Only 21 nodes will be able to verify the transaction. And who selects these nodes? So we were a block producer candidate for years. So what goes around there is there was an election for selecting 21 nodes. So everyone who a single user will be able to cast a vote. So if supposedly Ethereum is distributed around the world, if a single Ethereum is held by different, then everyone will have a vote. So that's how the community votes for him. So this is called a DAO, distributed autonomous organization. So it's an organization that's working with the community. Community is making the decision on how the application is going to move forward. There's no proper process.
So if this particular community has designated, okay, this particular node is going to be survived by EVM, isn't that an attack method? I think it's blocked and or deal of that particular node.
Yeah. So for EOS, the 21 candidates were Bitfinex, Kraken. There are large-scale exchanges, and they have a lot of computational and with proper due diligence of this selected as a node, and at any time, this node can be switched. When a community votes at a moment that this node has to be removed and the security flaw in this node will be removed, and there will be different nodes. Just like that, in Ethereum, there's different virtual machines set up across the world. So, okay. Wait for 5 minutes.
Sorry? Yeah, it is going live. You can. Yeah, sure. It is. Share the link of live broadcast. Yeah. So I hope everyone that they have basics on blockchain, right? That is nobody is there in like that is coming here for the first time and hearing about blockchain. So that was the base for this session. So that is why we start. It was started in between, like that is with a very short introduction on blockchain. Okay. So Ashok Kurier Bajikaran of Startup Kerala Startup Mission is here. So he just give us a brief introduction on the global impact challenge that is going to happen. Ashok.
So hi friends. How many of you know about Singularity University? Great, thank you. So Singularity University is a global community wherein there are a set of experts who are working on exponential technologies. So the Singularity University conduct impact challenges across the world. And now India have taken 3 challenges which are mainly focused on one, environment, healthcare, as well as education. So if you have any good ideas which are working on these cutting edge technologies, you can apply for that. The interesting fact is that tomorrow is the last date. So if you have good ideas on that, you can apply via the Singularity University website. We will be showing you more details on that.
Yeah, just play that video. Okay, so it is just like a hackathon, like that is you can apply for that. It is the concept is like there is the over the period, that is the technological advancements that is going to create a digital divide between people, right? That is after some years, people say like singularity, we will achieve singularity in 2045. Then people say like singularity in 2035. So do you know about singularity? What does it mean? So it is just like humans create robots or machines that become more intelligent than humans. Okay, as of now, our technology progressing in that way, so it is considered like there will be a digital divide at some point of time where technology will be accessible to some people and there will be resources that is not accessible to many. For example, even at some stage, natural resources get scarce. Water will not be available for everyone. There will be some people that is who have access to water and some people who doesn't. Education will also have a similar digital divide. So in 10 years or 15 years, there might be some situation that happens at that stage. So Singularity University is intended to motivate people to work on solutions to solve those grand challenges of future, to use the technology towards that. So here, if you have any idea on education, to make sure that education is available for everyone, or for resources, environment resources. Just for example, we consider like water as the biggest challenge, right? That is at some point of time, that is groundwater, it is getting decreased and there won't be water available for everyone. So if you consider Earth is covered 2/3 with water, but seawater is there. If you have an innovation that is you are coming like, oh, seawater can be converted easily, cheaper to drinking water, then there might not be any drinking water problem in this world. Or if you tell like this one, energy is one of the biggest concerns of the non-renewable resource, or petroleum, it is degrading and there won't be petroleum after some years. Solar cells, that is, it didn't make that much advancement over the period. That is, if we can find a cheaper solar cell or something that is accessible and available to everyone, that is, we may go to a stage where we think like energy is something free, right? So any type of innovation, any type of ideas, if you have, you can apply for this. And the biggest part is like, you do not need to worry about the resources that is required for making that possible. You just, if you have a solutions, if you apply for that, that is, you are getting to the visibility of the Singularity University, and it is headed by Ray Kurzweil, Peter Diamandis, etc., who are the known as the futurists or the biggest brains in the world, supported by Google and so that is, you do not need to worry about the resources, you do not need to worry about money to make it practically possible. So whatever innovation it may be, but only thing is like you need a solution for that problem. If anybody have that, please do attempt. That's all. So if you have any questions after this, we can discuss. Yeah.
Hello. 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 So,
and FAYA portrait is normally of asking basic questions. If you do not understand anything, feel free to ask that, shoot that question, and make sure that you get that point. Not like you do not what you think about me, like these are basic sort of questions. Just make sure that you ask the right questions and understand things.
So I think we have covered all this basic stuff. So now might be the time for questions. Any questions relating? Yeah.
What you are paying attention, you talked about yours and the 21 notes, and that's fine. And still that's on Ethereum. Ethereum works on a proof of work, right? As far as I'm aware,
So verifying a transaction itself is solving a cryptographic puzzle. Performing an Ethereum smart contract transactions will also cost you processing power. There's a lot of smart contracts operational at the moment, and most might be say token transfers and all. A lot of people in the world, around the world, might be transferring tokens among each other. If a single node has to verify all these transactions, perform all these smart contract operations, it's not possible. So processor intensive or specific tasks, these are handled by the Ethereum virtual machine, and these are packaged by as a transaction. These transactions are verified by these nodes. So that too, every node is not verifying every transaction, as I told. Randomly selected node will only be verifying a transaction. What you said might add to the security of the system if everyone could have verified a transaction, of everyone could have performed each transaction, but it's not practically possible. So
I get that. I get that all the miners, every miner will not be doing all of them. What I'm saying is that even anybody can be an Indian.
no.
Then how do you distinguish between
So Ethereum virtual machine is a distributed. So how do you distinguish between Amazon cloud services and Microsoft servers? How do you know where it is stored? You can't. It's a centralized service. Just like that, Ethereum virtual machine is for servers which are managed by the whole world. These servers might be handled by physical entities that we can't know anything about. So these are selected machines which are capable of performing these high throughput transactions, but these are managed by the whole network itself.
that's the whole decentralized model, right?
How?
About and some certain
So every transaction in Ethereum virtual machine, yeah, how this goes is like, so if this is an operation, say my smart contract has a function called addition, and you are supposed to send A and B for addition. So how my Ethereum transaction will go is like this. In my transaction field, there's a field called data. In data, I'll be sending the function name, the contract address, and the inputs A and B. This information is relayed between all the mining nodes and every node in the world. But they are not performing A plus B. Only the Ethereum virtual machine is performing A plus B. But this information, what all informations or what all state changes are made in the Ethereum virtual machine or around the blockchain, Ethereum blockchain, it's transferred between everyone. So that's how the integrity of the system is maintained. So I think that's about. Any more doubts? Hmm? No, Ethereum virtual machine, it's like my private code. What the code does or how the code behaves is none of the concern of the miners. Miners are only performing whether this transaction is legit. Like if someone is transferring A amount of tokens to send receiver B, so are A and B qualified for it? That is only function these miners are verifying. A plus B, if it's 6 plus 4, if it's done, that's being verified by the Ethereum virtual machine. It's the logic, the virtual machine is good. Only the transaction and its recipients, its contents, that's all and all are verified by machine nodes. So tools. So this was actually, yeah.
Transaction has to be a gas limit, right? Each transaction has to be a gas limit, right? So is there any possibility to means the gas limit will be a 0?
No, actually every transaction requires a gas fees, and this is the basic gas you need to pay for a transaction. If the data is 0, if you are not performing any state changing transaction, even that, then you need to pay $0.089 for a transaction to be relayed across the network. So I'll say an example. If I'm generating a transaction that's erroneous. If I'm transacting from A to B, and I was supposed to transfer from A to C, it will take a certain time for the transaction to get verified and added to the block. I can override the transaction. I can send value as 0. I can send data as 0, and I can just use that transaction hash itself for overwriting it. So then there's no data, then there's no value. You're transferring only 0 Ethereum. You're not sending this to anyone. You're not sending any data, but still you'll have to pay 0.089. This fees is for the network to relay the informations. Yeah. Miners. So as I mentioned, this consensus mechanism works is like how the network grows. So how many nodes there are, that much stronger the network is. So these nodes are verified, and then we talk about consensus. Why should I be a node? Why should I play a part for Ethereum? Like, I shouldn't host a mining node for Ethereum transaction. I can do it from my wallet, a web-based wallet. There's no need for me to run an Ethereum full node. Why? So there's need for an incentive. Why should people verify transactions? So there is an incentive. So people are using or spending their resources, their network time, their processing time, their power to, world's 2% is consumed by Ethereum or whole cryptocurrencies. Then how much power a system or a mining farm would take? So this costs real money. So they need some mode of payment for doing this to act as verifiers. So that's how mining rewards are spent. So this 0.089 or 89, this money is sent over to the network, and whoever verifies that transaction, he gets that money. Not a lot of it, there are separate divisions and all, but still, that's where this money is spent. Yeah. No, they won't get it. So that's in 2012. I told you, if I was running a Bitcoin node on my laptop, there was a high chance that I could have gained a lot of Bitcoin, because every day I might have verified tens or hundreds of transactions. Then for every transaction I am receiving point something Bitcoin. I might have gained 10 or 15 Bitcoins over a month or over a year. But right now, as the probability increases, as the number of nodes increase, probability of a single machine getting that mining reward is very less. As I told, a company will be having 10 million nodes, and so the probability is 10 million versus 1. So they will be getting the mining reward. They will be verifying tens and thousands of transactions without getting any reward, but they will be verifying other tens and thousands of transactions with rewards. Any node can be that lucky one if you have the numbers.
So I'm not mining Ethereum. I do run a node because the nodes are the power of the network.
Yeah.
So the nodes should be there even though they're not mining. There should be more nodes than so that.
So the nodes basic functionality is to perform transactions, to send a transaction, to receive a transaction, and to mine. These are the basic functionalities. Even if I don't have a node, I can send or receive transactions. There are web-based wallets, web-based light clients. I can do that. Downloading a full node, the main purpose is to view the blockchain and mine. These are the basic purpose. Your question is, even without mining, would there be a need for the node? There's no need. You should not. There are a lot of.
Actually, the transaction in the network should be recorded in all machines. So as the number of nodes in the network is increasing, that increases the availability of the network. So that's the reason why people are actually more voluntarily even though they are not using.
Yeah, maybe because this is a community effort. Like as I told, the 90% of mining powers is distributed by 10 and 11. So this problem to be is a major concern in the community. Centralization. So this is a decentralized network, and it's supposed to stay so. It's getting centralized. So how to tackle this? That's where different consensus mechanism. So someone might voluntarily run a full node to be a participant for the network, but he is not getting any incentive, so he need not. When proof of stake comes, it all goes back. My single system also has the same probability. So Ethereum, yeah.
So that means family $1 and $0.089 is like person was executing this contract, right?
That's what I said. Not the full amount, because you know bitcoins and ethereums are generated while mining. You might have heard of the term. Some ethereum, some bitcoins are generated during the transaction also. Some newly mined bitcoins. These are also sent to the network. So you can't satisfy 0.089 the whole world with 0.089. So there are some newly mined cryptocurrency also. But to maintain the integrity of the network, some fees are to be paid. Yeah. Yeah, please.
Ethereum is only the public permissionless blockchain. So that limitation is only that application is limited only for the cryptocurrency. No, it cannot be.
No, not exactly, not cryptocurrency, but one of the main limitations is you need Ethereum for performing a transaction on a smart contract or anything related to Ethereum network. That's one of the limitation. But as Ethereum virtual machine is a computer as a whole, any kind of transactions which are based on computational logic can be performed in Ethereum virtual machine.
So if you can go forward and see like
Yeah.
who actually went.
So just one more question. Yeah. So virtual machine, these are computers dedicated for performing these transactions. So miners are supposed to be individuals who are dedicating the time, money and effort for verifying transactions. That's why incentives are given to them. Virtual machines are set up by the community itself. So these machines are getting a lot of updates right now. So you might have heard about different releases. So all these releases are updated in virtual machines. They're called Homestead, a lot of new releases. When Casper is coming, Casper is the Ethereum's proof of stake protocol. When Casper is coming, the Ethereum virtual machine needs to be reconfigured. If these are different machines sitting at different locations are not at the control of Ethereum network, they can't make these changes. So Ethereum virtual machine in essence is a little under control of the community itself. So they are incentivized by the community. So in EOS, as I told, there are 21 block producers. They are incentivized by the community. So every transaction, you are not paying anything. In proof of stake, you don't have to pay anything for a transaction. The community is paying the nodes, the 21 nodes. You are not paying. So just like that, differences are there for EVM also. So tools. So anyone who is interested in going through with developments on Ethereum network and blockchain as a whole, need to have some sort of familiarity into these tools. So wallets, as I told, these nodes are the communication point between blockchain and your code. So your code will be hosted on a classical database or a classical website. This needs to have connection between the Ethereum virtual machine or Ethereum network. So this is where wallets come in. This communication, in the sense, as I told, there's $0.089 to be paid for every transaction. So every transaction is a monetary transaction also. So it's associated with wallets mostly, because you need to pay cryptocurrency. Either you need to have hard-coded public and private key into your consoles like Geth or Web3, or you need to use a wallet. If you have a simple wallet with say 1 Ethereum, you can do any transaction. A wallet can execute any transaction. It can behave on behalf of you, it can pay the money. So mist, parity, MetaMask, these are three wallets. MetaMask is one of the most important tool you need to understand. So I'll just show MetaMask. This is MetaMask. It's a browser-based wallet. It's a plugin for Mozilla or Chrome. Yeah. So this is a wallet, simple wallet. So the two accounts, account 1 and account 2. Let's start with the small account creation. So this is a newly created account. Etherscan is your default block explorer. So Etherscan can get you the details for wallets, the transactions, things like that. This was my newly created address. To create an address that's just like that. A new address is simply created, and you can have your private key exported, can copy address, you can generate a QR code. If I make a transaction, it will be listed on Etherscan like this because the blockchain is public. So MetaMask, one of the major advantages, if you are logging onto a site which uses Ethereum smart contracts and you are saying, say, some data operations, you are adding some custom data, you are typing in your name, register, you are clicking register. You need to spend some Ethereum. Then there will be a notification like this. MetaMask requires permission. Wait. So there will be a pop-up with MetaMask asking for a transaction. So there will be a pop-up with MetaMask for confirming that transaction. In that transaction, it will be specifying what gas it would be costing for the transaction, and the total Ethereum you'll be spending for the transaction. All the information, any data that are relaying, all this information will be passed. This is a browser-based example for a wallet, which is very user-friendly for every development. I'll show a demo later on. So these are wallets. Then there are development frameworks. So GETH is one of the most prominent IDE for Ethereum. It's the Go Ethereum client. So I'm running an Ethereum testnet right now. This is an Ethereum node. So GETH is a command line interface for running full node, light node, a minor node, creating transactions, uploading anything. So GETH is the default command line interface for Ethereum. So in Ethereum it's called Rpc Interfaces, remote procedure calls. So something on Ethereum, if you're executing a smart contract on Ethereum, it will have a function. These functions are called using RPC calls. This is called RPC APIs. So every transaction, every operation made on Ethereum virtual machines are called RPC commands. GETH is able to execute that command with the network. So in this command, I have specified it's a testnet. It's a sync port that's light, and this RPC. I'm enabling some RPC APIs, database, ETH, net, Web3 personal transaction pool, and RPC port. I'm doing a local thing. If I specify a port, I can connect to a specific node. So you're connecting, as you mentioned, what's the use for running nodes? Nodes also increase the connectivity. So if I have different nodes in Trivandrum or located in India, my network strength will be more. So this is also an added benefit for running nodes. You are connecting to a master node or a peer node. These peer nodes will be relaying back transactions to the mainnet. So then there's Truffle. Truffle is another development environment. So in Truffle, what's the use is that there might be different smart contracts. One smart contract might be interacting with a different smart contract. So all this need migrations. Migrations is, as I mentioned, these opcodes are being sent to the Ethereum network. This code as a whole is not being sent as a text document or a file. It will be a hexadecimal code, OXFC, some kind of code. It will be representing the whole code. This migration, converting your Solidity code into a basic operational code or object code or byte code, that's been done by the compiler. So Truffle is great for developing a huge network or system of network. Remix IDE is the basic simplest compiler you can find. It's a web-based compiler. You can log on to remix.ide and remixide.com, and you can paste your Solidity code. You can compile it, deploy it to the network. Just like that, you will get an address and your smart contract will be deployed. So Remix is the simplest thing, but the compiler is not too strong. You can't specify any migration. There are different limitations for development. So developers might be using Truffle, and if you want to try out how the network works, please use Remix. So testnet. Ethereum virtual machine, as I told, every transaction would cost certain money. So you can't develop on Ethereum virtual machine. So there are test networks. There are clones for Ethereum virtual machines. These clones cost any money. You'll be getting free Ethereum. So this is connected to the main Ethereum right now. There is a Robston test network, Coven test network, Ringaby test network, and local test networks. So these are three test networks which are just clones to Ethereum virtual machine. You can select the Robston test network and I have a balance of 0.023 test ethers. I don't have any real ether. This is a test ether. This is the ether for Ringaby Ropsten network. If I go to my Ringaby test network, the same address is having 8 ETH. So these are different networks. So here 8 ETH you can get for free. You can go to a Ropsten faucet. I can request myself 1 Ether, and if I go to my Ropsten, this is the faucet queue. Once this is confirmed, I'll have a balance. Yeah, it'll take time for. This was my address 15. I'll go to Etherscan. Let's see here. So the last transaction was 11 days and 20 hours ago. So my transaction has not still been processed. Once it's been processed, my balance will change to 1.25 Ethers. So this is a test network. You can get free Ethereum, and you can use these Ethereum for development purposes. And then there's the test RPC. Test RPC is a local test network. If you're just deploying test RPC or typing test RPC on your command line, you'll get 10 addresses, 10 public key, 10 private key, and each having 100 Ethereum balance. So these are test Ethereums, but you'll have accounts and balances then and there. There's no need for this kind of setups. But using Ropsten, Coin, and Ringaby, you can set up a network itself. If you are deploying your contract on Ropsten, and I'm also using Ropsten network, we are all having fake Ethereums or test Ethereums. I can spend test Ethereum, you can spend test Ethereum. The network will do the same thing. It will execute smart contracts, but it's still in the test network. That's only thing. So interface. This is where development comes in. So as I told, writing a Solidity code or a smart contract code is not that big of a deal. So interacting with this code is the most important thing. So your backend, your website's backend will be interacting with the Ethereum virtual machine or the smart contracts using Web3 codes. Web3 is the Ethereum's default framework. It's both built in JavaScript and also in Python. There are C instances, C++ instances also. You can use any. So in Web3.js, you can call Ethereum functions, smart contract functions. And one of the two most important features or things you need to call these functions are address and ABI code. So when you are writing a smart contract, it will have different functions. Say function would be subtract or add or something. So your code or your machine doesn't know how to interact with this network. So that's why an ABI code is used. When you're deploying a contract on the network, you'll get an ABI code. It's the application binary interface. So using this code and the address where this contract was deployed, using both of these, you can call an Ethereum function in that smart contract, and you can send data, collect data, things like that. So this is Web3.js and frameworks. These are two security frameworks used for token generation and crowd sale and all. Zeppelin and Ember. Open Zeppelin, if you go to the page, there are a lot of token codes and a lot of ICO codes, crowd sale codes available there. You can find that. So let's go ahead with a short demo on how to deploy.
Before moving to that, let me think in a normal developer perspective. That is, a smart contract is something that anyhow that is we are writing a code and we want to deploy it to Ethereum network, and there are different tools. For example, you told like that is we have to build it before deployment. And when I build it, and you mentioned about the API interface, and you mentioned about the code, that is code that actually gets shipped to the network. That is actual code that we write. For example, I write a code to add two numbers. Okay, so there is a smart contract inside that it is for adding to a simple example to add two numbers, and so I wrote in Solidity. So it is just like a normal something similar to JavaScript. I write the code for that. After that, I use a tool to create a build.
Bridge, yes. Once
it generates a hash code as well as an API.
Yeah. So once the contract is on the Ethereum network, it's accessible. It's live. Can be accessed by anyone. If you refer the smart contract address and API code for it. If you know both of these, you can access from any frontend.
So that is after deployment. I am talking about from a developer perspective. I am right. I want to deploy that. Once it is deployed, anybody can have access to that using the API that is generated, right? So initially, this is like this. I am writing the code. I want to deploy it. So
yeah. So that's these three things. Truffle, Remix, and Jet. So I'll show a small demo on how to deploy on Remix ID. So it's a web-based ID, so it wouldn't take time for. So Remix is also Ethereum's default web-based IDE. It's remix.ethereum.org. So this is a small Ethereum code for a KYC application. So let's not dwell a lot into the code. So this is a functional code. So what I'll do is I'll just compile here. Then there'll be warnings. These are to be ignored. These are some security warnings, which if you want to fix, you can, but these are no potential threats. So then you need to select contract. There might be different contracts. That's why I mentioned in a single smart contract itself, there might be multiple instances of contracts. So in Truffle, it's more easy to compile this together. In Remix, you can only compile a single code at a point. So contract user, this is your smart contract. If there was contract something else also in this code, then there will be two items listed here, user and contract something else. So this is a contract user, and there's a function also user. This is a constructor. So let's go to user. If you have compiled it, let's click on details. So the contract's name is user, the metadata, and this is a bytecode. So these are push 1, 080, push. These are stack traces for Ethereum virtual machine. So this is the API code. Yeah. No, these are the details for the smart contract. Once you're compiling it, you can generate its. Yeah. Some of them are for EVM. These bytecodes are for sending to EVM. This API code is for us to interact with the smart contract once it's deployed. How to interact with it. So there are a lot of details available there. this is the ABI code for it. So it defines what all functions are there, what all data type each function has, what's the values passed, things like that. So ABI code, then there will be a lot of other details which you don't need right now. Now let's go to deployment. Let's deploy this to a network. So environment. As I told, there are different networks you can choose to. We have seen MetaMask. MetaMask is an injected network. So in your web browser, when you are doing some functions, MetaMask will inject a Web3 instance to your code. So then it will be popped up, and only after processing this transaction would the code or the rest of the code will work. So this is injected Web3. Or you can use any other Web3s. Wait, yeah, wait. Can you see? So here, Web3 provider, there's 3 listed. So one is an injected Web3 for the local host, and the 2 others are for inferior nodes. It's connecting with external nodes. So if you're using MetaMask, you need to use injected Web3, whereby this Web3 is being pushed into your browser itself. Here, you need not have any connection to the Ethereum virtual network. Any data that's being done in this JavaScript file, the Web3 will send it to https ringaby.infura.that node. That's an Ethereum node. This data will be sent to that node and it will process. In the case of injected Web3, it will be sending this data to MetaMask. MetaMask will get some sort of confirmation dialog and say this much of Ethereum will be spent, and this transaction will be relayed by MetaMask to the node. So in the second and third case, you need to have a wallet with balance within the code itself. Like you can have transactions, you can have accounts, private keys from accounts, you can use it to view transactions. All of this can be done through Web3. If you are using MetaMask, you don't need to do all this. You just need to send a transaction, MetaMask will do the job for you. But if you are using separate instances, you'll have to do all this manually. So in Remix, let's go to run injected Web3 account. So here my balance is showing 0.25 because we are using injected Web3. Here also in the account it's showing 0.25. So the MetaMask is injecting data to the website. So gas limit, just a limit, it'll always be under that. Value, you don't have to use any value. Which contract to deploy? You are selecting user. You are selecting deploy. Then there will be a pop-up. This is the pop-up I mentioned about. Confirm transaction. Can you see? Oh. Confirm transaction. So this is a transaction from account to the new contract. And amount is 0 Ethereum. Gas limit is this much, gas price is this much, maximum transaction is this much. If I increase the gas price, the benefit is that my transaction would be picked up faster. So miners are looking for incentives. So they will verify the transaction which has the most gas fees, or the transaction they will get more incentives. So they will verify that transaction. So during ICOs, in some ICOs, the sale closes in 5 minutes. There is a ICO called run by Brave browser called Brave. So their ICO closed in 5 minutes to reach 100 million target in 5 minutes. So imagine the traffic Ethereum network will be facing at that point. A lot of transactions will be coming in, and Ethereum can only process this much of transaction in a limited time. So how to make sure you get the tokens and you are not left behind? So you need to increase the gas price. If you are sending a lot of gas price, then your transaction will be taken up first. So that's the gas price and gas limit. So I'll just, because I'm using test ether, I'll just select a random number and submit. The transaction has been sent. But it has not been yet reflected here. Oh, sorry. Their chain is resyncing. Yeah, so the transaction is confirmed. You have the reference number also. You can also do that. You can click on transaction and you will go to the transaction reference page. Transaction has been included in the block number 33815, but the network is supposed to reindex right now. So that's how you deploy a contract. And once you deploy a contract, this is the basic function for interacting with it. This is the backend function. This is the ABI code, and with ABI code and address, you can use contract ABI dot this address. You are using ABI and address to create an instance for user, and you can from now on call any functions for that user. I am just calling the function request new user, user.request new user, and I can send in the details and I can get back the result also. So I think that's about it. So these are the tools you need to get familiar with to start development on it. Yeah. Yeah. There is a gas limit also. We were increasing the gas price. No. When you are creating a transaction, you are sending the data along with Ethereum to the network, our account. When it is confirmed, that Ethereum will move from that transaction to whoever that's mining. So that's how it goes. Any more? Yeah. Sure. I'll share the slides and samples.
We are implementing the blockchain, a small bank. So in that case, we need to create one private network.
Yeah.
And how we can define the macro or either.
So yeah. So in the banking sector, actually, private chains are used like Hyperledger, Coda, many other platforms. Ethereum is a public network, and one of the main problem is that for banks, if every transaction are public information, they can know, or someone can trace back the transactions, and bank will be sending or displaying this confidential information, and they will be violating client confidentiality. So public network is out of choice. So two parts to it. You can implement it in a private chain using Hyperledger or Coda, where bank A and bank B are organizations, and transactions between bank A and bank B are verified by selected set of nodes only. No. So it's the permission chain. You can set permissions, like who will be verifying these transactions. So in banking side, let's say Federal Bank and ICICI is making a transaction. Federal Bank wouldn't want Canara Bank to verify the transaction. So in that case, Federal Bank, ICICI would be the verifiers, and also a superior authority or a third party authority, a central authority like RBI or NPCI as monitoring authorities. Then there will be informations. Which all informations will be shared? So if Federal Bank is sharing all informations or the address to ICICI Bank, they can trace back that address and know the transactions. If he's a account holder having huge balance, they can track him or trace him and get him to ICICI, things like that. So these corporates and these already existing financial systems wouldn't want public chains to be, so they want private networks. That's where permission chains and all comes in. And yeah, anything someone else was asking? So there's no ether actually in private chains. So no. So ether is just a currency for Ethereum network. In private chains, I can use a user issued assets. It's called UIAs. So in Hyperledger, I can say my organization Servant has an asset, say Servant coin. It's a user issued asset. It doesn't have any interaction with the network or any of the network components. Here, Ethereum is spent for every blockchain operations. There, it's not like that. You're just saying a number. User issued asset for you is 10. I'm saying 100. I can transfer 10 to you. It's only data transactions, and these data are verified by a selected nodes. You don't have to pay them incentives, so you don't need any Ethereum for them. So all these transactions is for their own benefit itself. So network management is done by them. Yeah.
You just deployed a smart contract, it takes some time for deployment. But what about the execution itself? What's the kind of time it takes?
So execution also is a problem. Time is a big factor. So the block time is 15 seconds, but it takes around, so every 15 seconds a new block is added. But when you send a transaction, it is normally executed after 51 seconds. So after say 4 or 5 block headers, your transaction will be added. So if you are sending your transaction right now, in the next 15 seconds or in the next block header, it won't be included. Only after 4 or 5 block headers, it's related to the network difficulty and the current transaction. So that's why I said in some ICUs, 5 minutes that ICU might close off. In that time, network will have a huge orphan rate. It's called orphan rate, when transactions are being dropped off. So that's one of the main issue Ethereum is facing right now, because smart contracts, if I'm typing in some data, for every operation it requires 15 seconds. So that's a huge problem. Oh, sorry, 51 seconds. It's a huge problem. It will be very slow, that slow actually. So they are going on different concepts like off-chain. They are implementing concepts like sharding. They are going to Casper protocol. They are trying out different things to keep data out of the original Ethereum chain. So from now on, original Ethereum chain is going to be only transaction specific. These smart contract executions will be taken out of this loop. So it will be called off-chain. So every transaction will be having off-chain. You don't have to download this whole block, because from now on this 120 GBs would be increasing. It will be becoming TBs, and not a single computer can handle it. So to
target micropayments, these has to be solved. Every simple computer, even a mobile phone, should be able to host a node. And for now, it's costing around 0.1, 0.08, sometimes $0.15, 15 cents for a transaction. So 15 cents in the sense, PayPal is charging only 2.9%. For any transaction under $15, PayPal is more safe. So micropayments, Ethereum is not yet there. For any transaction under $15, you are spending more on Ethereum rather than a credit card swiper. So you can't really buy a coffee using Ethereum economically right now.
That was there. I assume there's separate virtual machines for each of the test network, or
yeah. So these are separate virtual machines. So separate nodes.
Can I create a solution for an OEM?
So yeah, you can actually. It's not yet viable solution, and I don't know much about it. But there is the possibility of cloning the Ethereum virtual machine into a private network. You can host a private network, and whereby say you are defining 10 people and you are sending in 10,000 Ethereum to each, you can create a test network. And also a local network, local test RPC. I told about test RPC. You can just type test RPC, and in your command line there will be 10 accounts, 10 private keys with this much of Ethereum. So it will be local transactions. So anyone else? Yeah. No, the addresses are not related to Ethereum network itself. So if you're having an offline node in MetaMask, I've just created an account. If I turn off the Wi-Fi, I can create an account. No. Yeah. So there's no possibility of two people generating same private key and public key, because the probability itself goes. So if that happens, it's called an angle transaction. So when two transactions are the concurrency issue. In Ethereum also there's a concurrency issue. If two people are trying to change a data simultaneously, one of the transaction might get dropped. So that's just like two people. All of these are transactions. When you are registering an account and you are sending in Ether, it's a transaction. So when two people are generating, or at the worst probability, having the same private key and public key, if they are sending into that virtual network, first one will be considered, second would be rejected. So that's how the network is configured. Yeah. No, actually, yeah, that was about. I had one more demo, but that's not possible right now. So, any more doubts? Any feedbacks? Yeah, sure.
So actually, the slides and will be available. That will be shared, and you will also receive an email on feedback. We will also send you the link to all the and this session is also live stream. You can also replay the and do the session again.
Sorry? Sample programs.
I can send you by mail. I'll send you a.
So we will connecting him to the network, so you can also connect with him after that. So it was actually a much tough job for Sridhar, just because the mix of audience is like he has to start from all the way from blockchain, then come to this Ethereum, then come to smart contracts, and then go to give a demo. It is not something that is practically possible in 2 hours time. He was actually prepared for a long full session workshop where people come with laptops and attend the workshop. So the format of FAYA 80 is normally just like that, it is just to break the echo chambers, just to know that something like this exists, and these are the things that key terms that we have to know about it and go back and do more research and learn it. It is not like an end-to-end training program to fully understand and master this thing. That we normally have extended FAYA 80 sessions that are workshops, so we will surely have an extended FAYA 80 on it.
That's also why I didn't show a demo and showed how to deploy it, so that you may be more intrigued to do it yourself. So
all the key takeaway for this session is like that if you are new to Ethereum or new to this thing and you are a normal developer, just understand like the difference from which, just connect from your where you stand and what is the difference there on what there is some.
You need to understand about the network and how these things work. That's the basic stuff. The coding in Ethereum, the salty coding is just simple rubbish.
JavaScript or anything of that sort. That is, you do not need to worry about the syntax or anything on that. That is, you write code, you deploy it to network, or that is, it is about there are some transaction that is also happening in between, and then there is some code that we get to deploy to the network, and there is some some API that other application that interface with this smart contract and make use of it. So you just create a smart contract and deploy it, and it will be accessible to anyone that is use some API and communicate to that smart contract. Right?
Yeah.
So that is what I got from this, and thanks a lot, Suraj, for spending your time to prepare for this session and coming down to take this session. So I would like to appreciation to Sridhar. So there is also a small gift, Jasina. So I think like most of you are new to FAYA 80, right? First time you are coming here. Okay. So this is just like a technology session that happens on every month first Wednesdays. The aim is just bring one expert, one person who works on having hands-on experience in some technologies, and you could come and ask questions, whatever questions you have, if you are facing some trouble or if you want to learn something, some new technologies. And FAYA 80, as I said earlier, it happens on first Wednesdays every month, and this is the 62nd edition. So 61st edition. Okay. So it has been happening for the past 5 years, and this is the fourth session on blockchain technologies, and we will be having more in the series. And we have a Facebook group which was called Technogeeks. Right now it is FAYA 80 itself. So if you follow that Facebook group, then you should be knowing about all the technology events that we are conducting. And FAYA 80 stands for free knowledge sharing. That is, if you know something, you just come here, share what you have learned for free, because we are in a culture like that is when we want to learn something, we always go and pay, right? And many times that is the people who are trainers, they come and take session, not the people with the hands-on experience. So we want people with hands-on experience ready to share their experience, and that is where FAYA 80 came into existence.
Also, there are a lot of good communities, WhatsApp, Telegram, Facebook, regarding also in Trivandrum, Kerala Blockchain Academy, there are 2-3 good groups. So guys join and get updated on it, because it's evolving a lot. So you need to get updated every day.
And about knowing about these things, other than that, it is about building networks and building connections. And there is also something called blockchain interest group. So those who are really interested in blockchain, it is a group based out of Trivandrum itself. The event happens on third Thursdays, right? Every third Thursdays there is a meetup of blockchain enthusiasts here. That we can also connect you to that blockchain interest group if you are interested on that. Okay. And thank you for taking your valuable time and coming here for attending FAYA 80. Yeah. So if you want to stay back and ask questions or meet each other, we are fine with that. Okay. Those who want to.
virtual machine. It's a publicly visible virtual machine. When you do a test RPC project, where is the virtual machine?
So GF itself has a virtual machine image.
Okay.
Hi, sir. Right.
It's within GF.
Yeah. So അതിനകത്ത് തന്നെയാണ് എക്സിക്യൂഷൻസ്. സോ നമുക്ക് കോൺട്രാക്ട് അപ്ലോഡ് ആയി കാണിക്കും ഒരു അഡ്രസ് കിട്ടും. ബട്ട് ഇതെല്ലാം ലോക്കൽ
It will be within the